Welcome to this video on dimensions and how to fully constrain an object in sketch mode of Autodesk Fusion. First, this question: is it required to use dimensions in my drawings? And the short answer is no, not at all. This me-arm robot is laser cut out of wood, and this is the laser cut file, the drawing, and there are only 2 dimensions in. That is only to indicate the size of the wooden panel needed. The parts have no dimensions whatsoever, and still that me-arm robot comes out perfectly well. The DXF file used for the laser cutter contains all the needed dimension information without putting it in the drawing. Here's another example. If you would like to 3D print this keyring label, this is the drawing via which that design was made. There's no dimension in this drawing, it's just not needed. The STL file that you can send to the 3D printer contains all the needed information. If, however, you're on a more serious engineering project, then it can be very wise to fully dimension it if you expect in the future some changes may be needed. These blue lines, all blue lines mean they can be freely manipulated. That's not what you want. You want something like this, a fully constrained drawing. All the lines are black, and that means you cannot manipulate this anymore, only by changing the given dimensions. Note that these dimensions are for design purposes only. This is not the drawing you would send to your workshop to create this part. This is a technical drawing that can be sent to the workshop for them to manufacture this. This drawing also comes out of Fusion, but that's the subject of a whole new video. So here is this very important part that probably after prototype testing may need some changes. It is totally not dimensioned, but it can be manufactured. Let's have a look. If we try to make a change, it has to become a little bit higher, so I can drag this line up. Oh, that was not what we wanted probably. Also, if we need to make it a little bit wider, oops, that is probably entirely not what we want. These are the kinds of effects you can get with a non-constrained drawing. Now look at this very same part, but fully constrained. All the lines are black. That means I cannot even pick it up, I cannot even move any point around. The only way to make modifications is to change the given dimensions. Suppose after prototyping we found out it needs to be a bit wider. We can simply double click any dimension and change the number, and that fixed the problem. We have the complete topology staying similar, but it's only wider. Let's change the height from 40 to 50. By the way, you do not have to be in dimension mode. We can be simply in selection mode. Click a specific dimension and change the number. Look how any change I made keeps the complete topology intact, and that is what you want with an engineering drawing. Okay, the question now is, how can we add dimensions to, let's say, this drawing if we start with non-dimensions at all? Here is the part, or rather half of it, without any dimensions. Because it is a symmetrical part, we are going to use the mirror tool, which means we only have to dimension half of it, the other half will follow. In general, it also always is a very good idea to make maximum use of constraints like this horizontal line, or these parallel lines, or these 2 circles that are identical and the arc and the circle share the same center point. All these kinds of constraints help us minimize the amount of dimensions we need. Oh, here is, for instance, is a perpendicular constraint, which means we do not have to specify the angle between those lines. That helps to minimize the amount of needed dimensions to fully constrain this. To enter dimensions, we can click the D of dimension key on the keyboard, and we see that the cursor has changed. Then we can click, for instance, a line. Let me click this line. I can let go the mouse, so it's not drag, it's just moving the mouse. And I can as well horizontally as vertically position this dimension. Then click and then type in the number. Well, it already has the number of the current dimension of the line, so I only have to hit enter. And there we have our first dimension. To dimension this top part, we don't have a vertical line to click on, and that means we do it in a different way. Click on one line, then click on the second line, and then move away, and now we see that it calculates the distance between those lines is 20, or at least I want it to be 20, and there we have it. To dimension this circle and arc, we have to tell the size of it and the position of it. Let me click the circle, click and then drag away or move away. The current diameter is 8, that's fine with me. Hit enter and there we have it. To position it, let's do it with this line and then hit that circle again and say that is 10 millimeter, that's fine with me. Immediately also the outer arc has become black. That's because of this concentric constraint. Both the circle and arc are on the same center point. Let's move on to the larger circle, size and position. Let's click it and give it its diameter. And to position it, we have to look at the top and then hit the circle, and that is currently 16. That is fine with me. I also want to position it to this side line, and then either hit the circle or the center, it doesn't matter. You always get a dimension, and that is 20. That's perfect. This circle needs the same treatment. The size is already known because it has an equal constraint with this circle, but the position is not yet known. Let's do it to the side line. Let's say that is 10. Let me put it over there. And then, that is not exactly 10. Yeah, now it is 10. And then to the bottom line, do the same thing. And that also is 10. We are quite well on the way. Let's do the bottom line here. That is 20. Okay, fine with me. Let's do the line on an angle. Click it and then click the bottom line. And now if we move around with the mouse, we can choose where we want to put this dimension. Well, to me it seems like this is the most logical location, 45 degrees. There we have it. To fully constrain this line, we need to specify its length, and that currently seems to be 40, but also its height, or at least the distance from the bottom. Let me click both of them, and there we have 10. We also need to specify the vertical location of the slot. Let me click that line and then click the bottom line, and that is 20. That's fine with me. And also the width of that slot, click again, and that is 10. And there we have it. Now the only thing to do is specify the horizontal position of this center point. Let's take this side line as the reference. Click the arc and it should have become black. Yeah, it is if I click. Well, there we have it. Our complete drawing is now black. Everything is fully constrained. All I have to do now is mirror it. For that, of course, we are clicking on the mirror command. Then I double click on all the lines, or single click. Oh, and hold shift. Do I have to hold shift? No, I don't even have to hold shift because I first clicked that mirror command. This is all that I want to mirror. The next thing to do is select the mirror line, which is this one, and then hit OK, and there we have our drawing. Not completely constrained, because that part is still blue. Yeah, that has to do maybe with the total length. Let's go to this. Let's delete this dimension. I don't need it anymore. Let's give the total length of the part. Let's go to D and this line over here and this line over there. Click yes. If I make that 140, then my complete part is black, fully constrained, ready for engineering, prototyping, modifying, whatever we need in the future, we can now safely do without deforming this part. Well, this was it about dimensions. Maybe see you back in the future video, and in the meantime, have fun.